Hello there and welcome to Lower 6th Further Maths A-Level January mock exam preparation. We're on revision sheet 3 and here we're on question 1. So using the argument modulus form, okay, that's our first clue, or otherwise find the value of this complex number to the power of 9, write your final answer in x plus yi form. Okay, so the first thing I do with this question here is probably turn this complex number here into modulus argument form. Now this complex number is going to be a number that will be right by 3 over 2 and down by root 3 over 2. So on an argand diagram, this is going to be our complex number. It's going to be 3 over 2 minus root 3 over 2i. So that means when you break it down, it's going to have a 3 over 2 as its width on the triangle here to here, and we're going to have a depth here of root 3 over 2. Now the reason I've drawn a triangle in here is to work out the modulus. It's the distance from the centre to the complex number. And I've made a nice little right angled triangle here so that I can use the Pythagoras theorem to work out this distance. So it's 3 over 2 squared, add root 3 over 2 squared. So that's going to be root of 9 over 4. Add 3 over 4, so this is going to be 12 over 4. 12 over 4 is 3, so it's just root 3. So that's the argument. No, it's the modulus for this complex number here. The argument is going to be this angle round from here to here. Given that it's on the bottom as well, it needs a negative sign in front of it, so it's going to be negative tan of opposite over adjacent, root 3 over 2 over 3 over 2. And doing this on your calculator, you get minus pi by 6. Okay, so our complex number z is going to be written as root 3 times by cos minus pi by 6, add I sine minus pi by 6. Let's just check this on the calculator, so we can go to menu button and select option 2. Type in your complex number and press enter. Remember to get the I button up, you need the purple eng button here, so just press eng. You don't need to press any of the shift or alpha beforehand. Then click on the options button, scroll down once and then press option number 1 to convert your complex number into modulus argument form. Press enter and you get root 3, that is referring to here the modulus, and minus pi by 6 here, that's referring to the argument. Great, so we've got that right. It's really good to have that function on your calculator and know about it. So from here, now we just need to power 9 of our complex number. Now, using the sort of rules here that we had for modulus as an argument, if we wanted to find the mod of z squared, then we could just do the mod of z times the mod of z separately. You can imagine here what would happen with a 9 power. You'd have 9 mod z's multiplied with each other. So for the modulus, this is pretty straightforward. It's root 3 to the power of 9 here. But for argument, that's a little bit more tricky. The rule for argument, if you're finding the argument of z squared, is to add together your arguments. So arg of z, add arg of z. And you can imagine here what would happen if we had 9 as a power here. You'd add together 9 lots of these arguments of z. So this would actually be cos of 9 times minus pi by 6. So minus 9 pi by 6, add I sine minus 9 pi by 6. Okay, so we don't generally write this minus 9 pi by 6 as an argument here. We usually have our arguments in between minus pi to pi. So what we'd have here is if it's a minus, it's going around clockwise way from the positive real axis. So it's going to be minus pi by 6. That's past pi and then on another further point from up to here. So actually this angle 9 pi by 6 round from here to here is more likely to be written in complex numbers as just pi by 2. So simplifying this answer here, z to the 9 equals, now we can work this out, root 3 to the power of 9, that would be 81 root 3, and this would then be cos pi by 2 add I sine pi by 2. Now, now we have to convert this back into x plus yi form. Let's expand the brackets effectively here. Cos of pi by 2 is 0. Sine of pi by 2 is 1. So in fact our expanded answer here is just going to be 81 root 3 I. And that's our final answer. The reason we need an I here is because our 1 is times by an I here. So when you expand the bracket with this times this, you're going to get 81 root 3 times by 1i, so you get 81 root 3i. We can also check this on our calculator. Type in your complex number again, and then do answer to the power of 9, enter, and you get 140.3i, which is the same as you'd get if you do 81 root 3i. Okay, 4 marks.